Okay, this video is about isotopes. This was the video from way back on February the 12th, Thursday. Many of you were out because of school business. So we talked about isotopes. Isotopes are atoms of an element that have different atomic masses. Now I'm going to go through this pretty quickly. I'm going to split this up into two videos. But if you need to pause the video, pause it. If you need to go back and re-listen to something, do that. But I'm going to go through it pretty quick so it doesn't make a really long video. Okay, so isotopes are atoms of an element that have different atomic masses. Well, why do they have different atomic masses? Well, that's because the number of neutrons in the nucleus, the atoms have different numbers of neutrons in the nucleus. Okay, so remember that we've talked about how an element is made up of a lot of atoms. And all of those atoms that make up an element all have one thing in common. They all have the same number of protons because the number of protons identifies the atom. With isotopes, we can have different numbers of neutrons, but they still have the same number of protons. So this is a sample of carbon, and if this were a 12-gram sample of carbon, it would have 6.02 times 10 to the 23rd carbon atoms that would make up that sample. Out of that sample, some of the carbon atoms could have a mass of 12, or they can have a mass of 14. So when we're talking about an isotope, we're talking about a specific atom in the sample and not the average mass of the sample. So a carbon-12 isotope has 6 protons, as does the carbon-14 isotope. Now here's where they differ. The number of neutrons. A carbon-12 atom has 6 protons plus 6 neutrons. A carbon-14 atom or isotope has 6 protons plus 8 neutrons. So here's our difference. We've added 2 extra neutrons to carbon-14, and the 6 plus 8 protons plus neutrons equals the atomic mass there. Alright, so here are 3 symbols that tell you that you have an isotope. A lot of times I write them like this because it's easier to type this way up. That's carbon-12. This is carbon-12. This is carbon-12 also. Now the 12s that are there in each one of those symbols is the atomic mass. So when you're writing and telling everybody you've got an isotope, you have to write the mass. So you're telling everybody the mass of that one atom. Okay, and sometimes they write the atomic number on there, and so that's what the small number there at the bottom is. Okay, so to find the number of subatomic particles, that would be the protons, neutrons, and electrons, you're going to do just like we've done before, using the atomic number to get the number of protons and the number of electrons, because on the periodic table, the number of protons and number of electrons are equal to one another. So this is potassium, and potassium has atomic number 19, so it has 19 protons, 19 electrons. So it doesn't matter what the isotope is, what the mass of the atom is, it still has 19 protons and 19 electrons. The thing that's going to change is when we take the atomic mass minus the atomic number, we don't use the mass from the periodic table, use the mass that's given here on the isotope. So 39 neutrons, the atomic mass of 39 for the isotope minus the atomic number, or the number of protons, gets you the 20. So potassium 40 has a mass of 40 minus the atomic number, the number of protons, and you get 21. And then potassium 41, isotope potassium 41 has a mass of 41. Subtract out the protons that are there, you're left with a number of neutrons. So that's how you will calculate the number of protons, electrons, and neutrons from an isotope in it. And you just have to remember to use the mass that's given to find the number of neutrons, not the mass from the periodic table. Alright, so sometimes you are given a periodic table, you are given a table that has some information missing in here. Okay, and you have to fill out the parts that are missing. So to do this, what you have to do is, if you're given the atomic number and nothing else, it's just like the problems we've done in the past where you write down that you have 14 protons, 14 electrons, and you use the atomic mass from the periodic table and subtract that mass minus the atomic number. If you're given the number of protons and the number of neutrons, that's trying to lead you to thinking that you may have an isotope, just an individual atom and not a sample. So you would want to get the atomic mass by taking 47 plus 70. So that would be your atomic mass. The number of protons would give you the atomic number. You'd use the periodic table to look up the element. And this would be 47. And then what you would want to do is compare this number to the atomic mass on the periodic table. If that's the same, when you write the element symbol down, you will have, you would look up the mass element 47 on the periodic table, and if you have 117 for the atomic mass, then that's just the average mass. So it's just an element. If it's different, then you've got an isotope and you would have to record that mass.